I'm trying to figure out which one of these three graphs is the graph of y equals 1/5 to the x shifted to the right 1 unit. My first job is to figure out what this looked like before it was shifted. And what we know from yesterday is that the parent graph y equals 1/5 to the x is going to go through 0, 1, because all these parent graphs go through 0, 1. I know it's decay because that base is between 0 and 1. It's a fractional base. And I know, since it's decay, I'll want to look at what happens when x is negative 1, and I'll take the reciprocal of that base. So the next thing is to look at all these points and decide which of these graphs have these points shifted 1 unit to the right. Now, first off, this graph here, this guy, doesn't even make sense as an answer. That's a growth graph. We won't even think about this fella. Between these two, on all these graphs, I'm going to always show you guys 2 specific points, at least. Sometimes I'll show you a third. The 2 points I'll always show you are the point that would have been at 0, 1, and the point that would have been at whatever the base, however we're using the base. Like, I'll show you that point as well. So when you see these 2 points, assume that the point closer to that asymptote was the point that was at 0, 1, and assume the point that's further from the asymptote is the point that we got based off of whatever the base is. So for this function, those are the 2 points I'm looking at. Maybe it's this graph, maybe it's this point and this point. And the question becomes, these 2 points, are these points, do I get these by taking these and shifting them 1 to the right? Or maybe a different way to think about it is, if I have a point at 0, 1, and I have a point at negative 1, 5, and I shift these both 1 units to the right, is this where they're going to land? The answer here is no. Whereas over here, if I have the point 0, 1, and I have the point negative 1, 5, and they shift 1 unit to the right, they're going to land where these points are. This is the correct graph. And now, to summarize that whole crazy thought process that I'm sure was confusing, I would pick this graph, because this graph has these key points clearly shifted 1 unit to the right. As far as the equation goes, from our work earlier in the year, we know that for a left-right shift, we have the number chilling out with the x, and it's always the opposite of what you'd think. Like earlier in the year when I asked you guys about, hey, y equals x minus 5, quantity squared, plus 2, we know this is a unit, like a shift of 5 to the right, and this is a shift of up 2. So the number with the x is the left-right shift. It's the opposite of what you think. The number that's not with the x is the up-down shift, and it is what you'd think. This is a left-right shift. So the number will be up in the exponent with the x. And it's also to the right, so we'll do the opposite. We'll do minus 1. The equation for this graph is going to be y equals 1/5. And then up here in the exponent, it'll be x plus 1, because it has to be the opposite. The domain of the function is going to be how far to the right and how far to the left I can go. I can go to the right forever. And as I go to the left, there's no invisible walls, there's no boundary lines drawn. As I go to the left, it ends with an arrow. And so it goes to the left forever as well. That domain is all real numbers. The range, the graph, I'm going to do this in blue, graph goes up forever. And as it comes down, it starts to get closer and closer to this boundary line. But it never actually reaches that boundary line. That boundary line is at y equals 0. So the graph will get closer and closer to 0, but never quite reach it. So the range is going to be y is bigger than 0. Not even equal to, just bigger than 0. And then the asymptote is just that line itself, y equals 0. It's a little overwhelming at first, I'm sure. We'll try the next one, and as you do a few of these, you'll see it's pretty much kind of the same thing over and over again. And you'll get there.